TurboCalc is a breakthrough software that combines the disciplines of sketching, calculations, and optimization in a single application that enables users to solve a wide range of engineering challenges while making informed decisions. Here's a simple example that will show the fundamental facilities of the software. So first I will use a sketching tool from TurboCalc's parametric sketching facility to sketch and constrain the boundary of an arbitrary shape. Next, I will apply the game-changing graphical calculation technology in TurboCalc that virtually eliminates tedious mathematical calculations, programming, and equation solving from the engineering calculation process. To calculate the area, I take the calculation tool, click a point where I want to see the result, click on the geometry. The tag for the geometry, augmented by the area calculation built-in function, is automatically placed in TurboCalc's formula bar. There are 88 such built-in functions available in TurboCalc's formula bar that can communicate with geometry, dimensions, and empirical values in the worksheet to help you to automate a wide range of engineering calculations. So here is the area. In TurboCalc, you can work with millimeters, inches, or any unit system of your choice. Unit checking is performed automatically for every calculation. You can also use the dimensions to automate a calculation. For example, I want to calculate the distance between the centroid of the shape to the edge. So take the dimension tool, constrain one end to the endpoint, the other one to the centroid, and here is that calculation. And now if the geometry changes, you'll see just like a spreadsheet, everything is updating automatically in real time. Conversely, I can assign a goal for this calculation and backsolve the exact geometry that satisfies the desired goal using just 4 mouse clicks. So I want, let's say, the area of the shape to be equal to 1500 millimeters to the power of 2. So now I can select any geometry which is participating in creating this result. Let me backsolve the length of this line. So click on the goal seek command, click on the actual value, which is the calculation I just performed, to the target value is the result I specified by changing the length of the line. And here is the solution. And here's an example that shows how the technology is applied in real life. Here TurboCalc is set up to calculate the deflection on a cantilever beam. Notice that the beam has a non-standard cross-section. That means section properties are not available in any handbook. The beam's geometry was sketched and constrained using TurboCalc's parametric sketching tools, and the deflection calculation is being performed in TurboCalc's formula bar using the built-in functions which are communicating with the empirical value, the dimension, the empirical value, and the geometry in the worksheet. And now I can backsolve the size of the hole in the section to get my design goal satisfied. Click on the actual deflection in this cell, which is the calculated value. Target deflection, click on it by changing the radius of the hole. So with TurboCalc, you can specify design goals for any calculation, such as area calculation or cost, weight, anything that can be calculated. You can assign a goal and have the computer backsolve the exact geometry using just 4 mouse clicks. The single biggest advantage of TurboCalc over mathematical software is that the geometry and the calculations are associated in the same worksheet. So when the geometry changes, the calculation results are updated automatically. Here, if I specify a new length for the actuator, the geometry will change, which in turn will change this dimension, which will change this geometry, and the aperture area, which is communicating with this geometry, will update automatically. In TurboCalc, very often you can obtain graphical solutions without performing any tedious calculations at all. Here the user has set up TurboCalc to calculate the forces on an automobile seat using this force vector diagram. So as a seat back angle is specified, the forces are recalculated automatically. In this example, the user was able to uh, eliminate several worksheets worth of spreadsheet calculations. You can also set up dimension-driven calculations. For example, here the load distribution in this bike are a function of the dimensions here. So if I specify a new height for the bike, the parametrically defined geometry of the bike will change and the load distribution will be updated because these dimensions will change. You can also apply the goal seek technology to back solve a dimension. Here I want the centroid of the part to be exactly 75 millimeters away from this end. The variable is the length of the slot. So goal seek, click on the actual value of the dimension, then click on the target value and change the length of the slot to get the answer. And finally, the quick feedback from TurboCalc encourages users to perform what-if analysis of their engineering options. Here the user wants to know, what if a hollow shaft was used instead of a solid shaft here? So the shafts are made equal in strength by making the resisting moment under torque of the hollow shaft equal to the solid shaft by changing the outer radius of the hollow shaft. And in the process, the user finds this is the amount of money that will be saved when 1,000 shafts are used. Best of all, TurboCalc is priced to justify itself on every engineer's desktop. Thank you.